Today we're still looking at the trigonometric ratios. Today we're going to look at how to apply the trigonometric ratios when we're using the angle of elevation and of depression. So your first question is, how do I use trigonometry to find missing measures? Your learning intention. I'm learning to use the trigonometric ratios to find those missing measures. So you've got two warm-up questions. The first one, you've got triangle ABC, and you're going to find the tangent, sine, and cosine of B, and then the measure of angle B and measure of angle C. So pause the video now and see if you can do that on your own. Remember, it's always helpful to write out that acronym that we've been looking at. So, TOA. Sine, opposite over the hypotenuse. Cosine, adjacent over the hypotenuse. Tangent, opposite over the adjacent. Can you do that? What is the tangent of B? Remember, if you can simplify the fraction, that's part of finding the sine, cosine, and tangent. I hope you tried to do it on your own. The tangent of B, we're looking at the opposite over the adjacent. If I'm at B, opposite is 24, adjacent is 10. I can simplify. Both of those have a factor of 2. 24 divided by 2 is 12. 10 divided by 2 is 5. I can always use my calculator if I have trouble simplifying. 24 divided by 10, hit your math button, enter, enter. 12 over 5. And if you can always check your answer, also doing it that way. Okay, so the sine of B, sine is the opposite over the hypotenuse. My opposite is 24. My hypotenuse is 26. When I simplify, both have a factor of 2. 24 divided by 2 is 12. 26 divided by 2 is 13. And I have simplified. And then finally the cosine of B. Cosine is your adjacent over your hypotenuse, which is 10 over 26. I can simplify. Both of them have a factor of 2. 10 divided by 2 is 5. 23 divided by 2 is 13. I found and simplified all three of the trigonometric ratios from angle B. So how do I find the measure of angle B? I use one of the three, and I use the inverse button. So if I'm looking, does it matter which one I use? No. I'll just choose the tangent. Tangent inverse of 12 divided by 5. And this will be an approximation. To find my tangent inverse button, I have to use the blue button. And then tangent. Tangent inverse of 12 divided by 5, I close it, and I end up with 67.38, round to the nearest tenth, 67.4. Okay, now to find and this is the measure of angle B. Okay, for the measure of angle C, you can either use your tangent inverse button again and find one of the three. Find the tangent of C and then use your tangent inverse button again, or you can simply realize if this is 90 degrees, these two added together are also 90 degrees. So I can take 90 degrees minus 67.4 degrees, and I end up with 22.6 degrees. So if you were having trouble remembering and did not try the first one on your own, pause the video and see if you can do the next one on your own. Okay, I want you to look. If this is uppercase K, this is lowercase k. The side directly across from the angle will be the same number, letter of the alphabet, but your vertex is labeled with a capital letter. Your side will be labeled with a lowercase letter. If this is J, this would also be J, I, and I. So the measure of angle K. I know the measure of angle I, and I know together they add up to how many degrees? 90 degrees. So I'll take 90 degrees minus 49 degrees, and that gives me what? 41 degrees. Okay, now to find I can use any, to find the length of I can use either sine or tangent. Both of them use the opposite side from 49. If I want to use 41, I can use the cosine or tangent. If I'm looking again, I realize I can't use tangent because I only know one of the two legs. That means I've got to use either the sine of 49 or the cosine of 41. I'm going to use the sine of 49. The sine of 49 degrees is equal to, the opposite is I, divided by 8. What do I do to solve? Well, I've divided by 8, so I'm going to multiply by 8. In your calculator, 8 times the sine of 49 degrees. Close it off, and I get approximately 6. Okay, now, there's several different ways I can find K. I can use the cosine of 49, I can use the sine of 41, or I can use the tangent of either side, or I can use Pythagorean theorem. There's lots of ways after you get two sides to find that third one. I think I'm actually going to use I'm going to use 49 again, and I'm going to use the cosine of 49 degrees. And that will equal K divided by 8. The reason I'm using the same angle is for you to show you the flow of this. We're doing the same process again. We'll multiply both sides by 8. Eight times cosine 49, close it off, hit enter, and I get 5.24, which is approximately 5.2. Okay, now thinking a little bit harder, what if I would have tried to use the Pythagorean theorem? I've got my hypotenuse and I am looking for a leg, so that means I will subtract. It would be 8 squared minus 6 squared. Hit enter and it's 5.29. So I'm a little bit off with the sine, cosine, and tangent ratios. If I would have gone out to another decimal, I would have been a little bit closer, but I did not. So if I would have gone out to 6.1, I would have gotten 5.17, which is a little bit closer to 1.2. So that is how you use the trigonometric ratios to find different side lengths. So now we're going to work on some word problems. You've got a guy on top of a fence. He sees a lion on the ground at an angle of depression of 24 degrees. If the man and the fence is 4.2 meters high, how far is the man from the lion? So if you're looking at that, I'm not sure I would call that X. I think I would call this X. We'll find them both though. I think I'll call this Y, so I'm not using the same variable for both sides. Okay, so what do we know? This is my angle of depression. I also know that these two lines will be parallel. If this is 24, this angle too has got to be 24 degrees. Alternate interior angles are congruent. So the next step is to decide which one of the trigonometric ratios we want to use. This is my side opposite. This is my hypotenuse. This is my side adjacent. To find X first, opposite and hypotenuse is sine. So the sine of 24 degrees is equal to the opposite, which is 4.2, divided by the hypotenuse, which is X. If you remember, I told you that I would show you the math one time, then I expected you to remember to flip-flop if the X is at the bottom. The reason is you multiply by X and then you divide by sine of 24. So X is equal to 4.2 divided by the sine of 24 degrees. One thing you always want to do is to make sure you're in the correct mode. I did not do that. We are in degree mode, so we are good to go. 4.2 divided by the sine of 24, and I get approximately 10.3. And that would be meters. Okay, what about Y? Well, the same thing again, except opposite over adjacent is tangent. So the tangent of 24 degrees is equal to 4.2 divided by Y. Once again, I expect you to remember just to flip-flop these two. So Y is equal to 4.2 divided by the tangent of 24 degrees. Okay, now this is the actual number. This is not an approximation. We don't get the approximation until we put it into the calculator. .2 divided by the tangent of 24, and you get 9.4. That would be 9.4 meters. So I hope it's been helpful looking at these word problems and going through the process. Jimmy is flying a blimp. The angle of depression to his landing spot is 23 degrees. He has an altitude of 2,300 meters. Determine his horizontal distance to the landing spot. So, highlight what's important. We've got the angle of depression, altitude, and the horizontal distance is what we're looking for. So if I create myself that picture, here's my blimp. So this is at an altitude of 2,300 meters. This is what we're looking for, is that distance. What we know, that angle of depression is 23 degrees. This is his landing spot. How do I find x? I don't know the hypotenuse. I know a leg, and x is the opposite leg. I do know, or the adjacent actually. If this is 23, alternate interior angles are congruent. This is also 23 degrees. Opposite, adjacent is tangent. So the tangent of 23 degrees is equal to 2,300 meters divided by x. Remember to flip-flop those. And x is equal to 2,300 divided by the tangent of 23 degrees. Now, this time it'll be an approximation. That this is actual. When we put it into the calculator, we get that decimal approximation. Which is 418.46, so that would be 418.5 meters. So Jimmy is about 5,418.5 meters from the landing spot. Okay, for the next one, we've got a ladder leaning against the wall. Its base is 3 feet from the wall. Determine the angle of elevation. So if we're looking at this, what does it look like? Here's my wall, and here's my ladder. Okay. Its base is 3 feet. This is 3 feet from the wall, and it's a 12-foot ladder. And this is what I'm looking for. That's your angle of elevation. So, sine, cosine, or tangent. What two pieces do I have? If I'm looking at this, I'm going to call this A just because I need a variable for when I set up my equation. Here's my opposite. I do not know my opposite. That means I cannot do sine or tangent. That leaves me with cosine. So the cosine of A is equal to 3 over 12. Which is equal to 1 over 4 when you simplify. Did I need to simplify? No, because I'm looking for an angle measure. So then we use our inverse button. Cosine inverse of 1 over 4 is approximately. Remember to get that, it is second cosine 1 divided by 4, close it off, 75.5 degrees. That's a pretty sharp angle if you're going up a wall. The angle of elevation is about 75.5 degrees. That brings us to our last one. When you're doing word problems, if they do not have a picture, you always draw the picture. You need to be able to accurately see what you're looking for. An angle is flying at an altitude of 12,000 meters. From the pilot, the angle of depression to the airport tower is 32 degrees. How far is the tower from a 12,000 meter point directly underneath the plane? So if you're looking at this, here's your altitude of the plane, here's your angle of depression, and we're looking for this. What do we know? Well, we quickly know that this angle is also 32 degrees, or we can find the other angle by taking 90 degrees minus 32 degrees, and that would be 58 degrees. Now, you want to use sine, cosine, or tangent? Well, you want to use tangent of 58 degrees or tangent of 32 degrees. You do not know the hypotenuse, you cannot use sine or cosine. Which shall we use? Well, if I use 32, then my x is underneath. If I use 58, then my x is on top of my fraction. So I think I'll use the tangent of 58 degrees is equal to x divided by 2,000 or 12,000 feet. Actually, it's meters. So I've divided by 12,000. The opposite is to multiply by 12,000. 12,000 times the tangent of 58 degrees, close it off, equals 19,204. X is approximately 19,204 meters. The plane is about a horizontal distance of 19,204 meters from the tower. So I hope you enjoyed doing the word problems. The last ones I did not highlight. If you're doing them on your own, I would suggest that you do, because it brings out what you need to be looking at. So how do you know you're successful? You know you're successful when you can use the trigonometric ratios to find missing measures. Those trig ratios and finding angle measures. We use the inverse button. Okay, now I've made a real quick summary. If you notice, find angle measures, I put inverse over here so I could remember how. So I hope if you have any questions, back the video up and watch it again.